Great day, grade 8 learners! Welcome to another interesting and productive learning math experience. What are you waiting for? Grab your pen and paper, your self-learning module, or your compendium of notes, and together, let's rock math. This week, we will learn about operations on rational algebraic expressions. With that, let's start off with multiplying rational algebraic expressions. The product of two rational expressions is the product of the numerators divided by the product of denominators. In symbols, we have A over B times C over D is equal to AC divided by BD. And remember, BD should not be equal to 0 because a 0 denominator will make the product undefined. The process of multiplying two rational expressions is shortened by cancelling factors common to both numerator and denominator. Now, let's have some examples and learn the steps to find the product of rational algebraic expressions. For our first example, let us find the product of 5t over 8 and 4 over 3t squared. The first step is to express the numerators and the denominators in factors. 5t can be expressed as the product of the factors 5 and t. 8 can be expressed as the product of the factors 4 and 2. 4 will remain, and 3t squared can be expressed as the product of the factors 3 times t times t. Our second step is to cancel common factors. Remember that we cancel factors which are common both in numerator and in the denominator. In this case, can we cancel 5? No, because 5 is present only in numerator. How about t? Yes, we can cancel 1t in the numerator and another in the denominator. How about 4? Yes, because 4 is both present in the numerator and in the denominator. Our third and last step is to simplify. After cancelling similar factors, we're left with 5 in the numerator and we have 2 times 3 times t in the denominator. And if we further simplify, the result will be 5 divided by 6t. Therefore, the product of 5t over 8 and 4 over 3t squared is equal to 5 over 6t. Now, let's have another example. Let's find the product of m squared minus n squared over mn and mn over m plus n. Again, our first step is to express the numerators and the denominators in factors. Among the polynomials present both in numerator and denominator, which polynomial do we still need to express in its factored form? Yes, it's m squared minus n squared, because the rest are already prime polynomials. If you can notice, m squared minus n squared is in the form of sum and difference of binomials. Using the skill that we have learned from the sum and difference of binomials, we can easily express m squared minus n squared as the product of m plus n times m minus n. Our second step is to cancel common factors. Now, we have m plus n times m minus n over mn times mn over m plus n. Remember that we cancel factors which are common both in numerator and denominator. Can we cancel m plus n? Yes, because m plus n is both present in numerator and in the denominator. How about m minus n? We can't, because m minus n is present only in numerator. How about mn? Yes, because mn is present both in numerator and in the denominator. Our third and last step is to simplify. After canceling common factors, we're left with m minus n in the numerator and 1 in the denominator. And as we all know, m minus n over 1 can be further simplified as m minus n. Therefore, the product of m squared minus n squared over mn and mn over m plus n is m minus n. Now, let's have another example. This time, we will find the product of 3y plus 3 and y plus 4 over y squared plus 5y plus 4. Step 1 is to express the numerators and the denominators in factors. We have 3y plus 3 over 1 times y plus 4 plus 5y plus 4. Which among them do we still need to express in its factored form? Do we still need to rewrite the factored form of 3y plus 3? Yes. If you can notice, we can still factor out 3 from the first and second term. Thus, we express it as the product of 3 times y plus 1. How about y plus 4? Y plus 4 is already a prime polynomial. How about y squared plus 5y plus 4? Definitely, because y squared plus 5y plus 4 is a general trinomial. Remember the steps in factoring general trinomial? In this case, we need to find the factors of 4, whose sum is equal to the literal coefficient of the middle term, which is 5. In this case, it is positive 1 and positive 4. Therefore, the factored form of y squared plus 5y plus 4 is y plus 1 times y plus 4. Let's proceed to canceling common factors. In this case, can we cancel 3? No, we can't because 3 is present only in the numerator. How about y plus 1? Yes, y plus 1 is both present in the numerator and in the denominator. How about y plus 4? The same goes with y plus 4. We can cancel y plus 4 because it is common in the numerator and in the denominator. After canceling common factors, we can now simplify these terms. In the numerator, we're only left with 3, and in the denominator, we're left with 1, and 3 divided by 1 is definitely equal to 3. Therefore, the product of 3y plus 3 and y plus 4 over y squared plus 5y plus 4 is equal to 3. We're done with multiplying rational algebraic expressions. How is the experience so far? Can you understand and follow? For sure you are, and you'll get better with continuous practice. This time, let's proceed in dividing rational algebraic expressions. The quotient of two rational algebraic expressions is the product of the dividend and the reciprocal of the divisor. In symbols, we have A over B divided by C over D is equal to A over B times D over C, and that is equal to AD over BC, where BD is not equal to 0. We can easily divide rational algebraic expressions by following these steps. First is to multiply the dividend by the reciprocal of the divisor. Second is to factor all the numerators and the denominators completely. Third is to divide numerators and denominators by common factors. And the fourth and last step is to multiply the remaining factors in the numerators and multiply the remaining factors in the denominators. With that, let's apply these steps in finding the quotient of 6 over 9c squared and 12 over 27c squared. The first step means the dividend will remain as 6 over 9c squared, and we get the reciprocal of the divisor, which is 27c squared over 12, and let's proceed to multiplication. Now, let's factor the numerator and the denominator. 6 over 9c squared will remain as 6 over 9c squared. 27c squared can be written as the product of the factors 9, 3, and c squared. And 12 can be written as the product of the factors 6 and 2. Now, let's perform step number 3. Is 6 common both in numerator and in the denominator? Yes. How about 9? 9 can also be cancelled because it is present both in numerator and in the denominator. How about 3? No, 3 is only present in the numerator. How about c squared? Yes, c squared is common both in the numerator and in the denominator. Now, we identify the remaining factors in the numerators and in the denominator. In this case, 3 is the only remaining factor in the numerator and 2 is the remaining factor in the denominator. Therefore, the quotient of 6 over 9c squared and 12 over 27c squared is equal to 3 over 2. Let's have another example. Find the quotient of p minus 2 over q squared plus q and p squared minus 4 over q plus 1. For the first step, our dividend will remain as p minus 2 over q squared plus q. And then we get the reciprocal of the divisor, which is q plus 1 over p squared minus 4, and let's proceed to multiplication. Among the polynomials present in numerator and in the denominator, which polynomial do we still need to express in its factored form? P minus 2 and q plus 1 are both prime polynomials. How about q squared plus q? If you can notice, q is both present in the first and second term. Therefore, we can factor out q, and thus, we can rewrite it as the factors q times q plus 1. How about p squared minus 4? If you can notice, p squared minus 4 is in the form of sum and difference of binomials. Using the skill that we have learned from the sum and difference of binomials, we can easily express p squared minus 4 as the product of p plus 2 times p minus 2. Now, we can divide numerators and denominators by common factors. Is p minus 2 present in both numerator and denominator? Yes. How about q plus 1? Q plus 1 is present both in numerator and in the denominator. The remaining factor in the numerator is 1, and the remaining factors in the denominator is q and p plus 2. If we further simplify this, we have 1 over pq plus 2q. Therefore, the quotient of p minus 2 over q squared plus q and p squared minus 4 over q plus 1 is equal to 1 over pq plus 2q. Let's have another example. Now, let's divide n squared minus 25 over n squared plus 5n by n plus 5 over n. For the first step, we multiply the dividend, which is n squared minus 25 over n squared plus 5n, to the reciprocal of the divisor, which is n over n plus 5. Now, let's factor the numerators and denominators completely. N and n plus 5 are already prime polynomials. How about n squared minus 25? If you can observe, n squared minus 25 is in the form of sum and difference of binomials. Using this skill, we can rewrite n squared minus 25 as the factors of n plus 5 and n minus 5. How about n squared plus 5n? If you can notice, there is the presence of n both in the first and second term. Thus, we can factor out n and rewrite it as the factors of n times n plus 5. As the result of step 2, we can now easily divide common factors. Is n plus 5 present both in numerator and denominator? Yes. How about n minus 5? No, n minus 5 is only present in the numerator. How about n? Yes, n is present both in numerator and in the denominator. The remaining factor in the numerator is n minus 5, and the remaining factor in the denominator is n plus 5. Therefore, if we divide n squared minus 25 over n squared plus 5n by n plus 5 over n, the result will be n minus 5 over n plus 5. And that is it for the first two operations on rational algebraic expressions. I hope that you have learned a lot from today's session. To wrap this up, let's have an evaluation. So grab your pen and paper and let's solve together. Find the product and quotient of the following rational algebraic expressions. I will give you 10 seconds in each of the problem. If it is not enough, you are free to pause this video and reveal the answer when you're done. Let's start. The product of 5x squared over 14 times 7 over 10x squared is equal to 1 over 4x. The product of m squared minus m minus 2 over 5a times 10a over a plus 1 is equal to 2m minus 4. The quotient of 5y squared over 9 divided by 15y cubed over 27 is equal to 1 over y. The quotient of 3b squared over b plus 2 and 6b raised to 4 over b squared plus 5b plus 6 is equal to b plus 3 over 2b squared. How many items did you get correctly? Who among you scored a perfect score? Wow, you are off to a good start. Who among you got a score lower than 4? Don't worry, you are also off to a good start. You just have to review your solution, check what went wrong, and redo it. Remember that it is not how fast or how long you do it. What matters is you keep practicing until you can do it. There is nothing wrong with learning at your own pace. Anyway, this has been Teacher Mark saying that math matters. See you next time!